Hi, I'm Joe with Antunes, and we're going to talk about error 17 on the ESDZ 1200. Okay, so we're going to be talking about error 17, which could be multiple causes. It could be something as simple as a open high limit, and it's a simple press on the back of the button, or we'll get into more complex things when we go through testing. Okay, so this unit is the ESDZ 1200. We're going to take off the bottom panel. This usually has 10 screws in the bottom. Most of them removed to make this faster for video. There are 3 on this side, 2 here, 3 on this side, and then 2 on the very back panel. They're about 1/4 inch off the bottom. Go ahead and remove these screws. All right, the panel will open this direction because of the wiring. What we're going to do now is I'm going to take part number 3080-159, which is a thumb screw. You don't have to use these, it just makes it easier. You can use the regular screws to do this, and we're just going to use it to hold the panel. Once again, we're just using it to hold the panel. You want to get it as snug as you can without damaging the gasket. All right, so we're going to check for the very basic high limit. Now what we're going to do is we're going to check to see if you've already tried pushing the buttons in on the back and it's still not resetting. We're going to check for resistance to see if we have an open circuit right away. This is not an endorsement of tools. This is just the one we happen to have on hand. And I'm going to set this for ohms. All right, the upside down horseshoe. And then we're going to check it from the blue wire, which is the one coming right out of the control board. And then we're going to go to the yellow wire, which is the one going back into the control board, but also goes to the contactor. This is showing we have continuity. All right, so this is showing continuity, 0.1. Now, if there's high resistance in there may also be a bad high limit, but right now it's testing good. So we can also check, if we get open, we can actually check each individual terminal on the high limits. So blue to the orange, and we have continuity. All right, do the same thing on the yellow wire to the orange. I think I should just stay here because the orange is a jumper wire, and we have continuity. If these were to read OL, say this is reading OL, then we know this one is stuck open and to replace it. Even though you try resetting it, it's still not going to work. It's damaged internally. Once again, OL, open, continuity, it should be okay. Now, another cause of error 17 is when you take off the bottom panels here to check the insulation. If it's full of grease, that's a good indication the high limit is damaged due to the grease. The best way to think about it is a halogen bulb. If you ever touch it with your fingers, you know that the grease from your fingers is going to hold the acid from your fingers on the bulb and etch it, and then it's going to shatter. The high limits can do something similar. They're not going to shatter, but they can create like a little fissure, a little pinhole, and it leaks out the pressure. That's what causes it to fail open. So if you see a lot of grease in here, the panels on the insulation, good indication that it's leaking down through the center. And when we turn the unit over, we'll explain how to correct that after you change the insulation. We can also move over to the control board to test as well. We can also check this for voltage to see if we get proper voltage from the board to the relays, or excuse me, the high limits. All right, so on the control board, we're going to take off the cover here. We're going to have to take off these little nuts over here. I have to grab a tool. Okay, so now we're on the control board side. There is a nut here. It's already been removed. I'm taking the one off the back side to remove the cover. Okay. Now, what we're going to do is make sure the unit is power is not applied to the unit, so the unit is unplugged. And we're going to test just to see if we have loose wires. Sometimes these connections get loose on here. So what we're going to do is unplug it from the control board, and you'll see a white, a black, a blue, orange, and a yellow in there. Okay. These are like a Scotch lock type connector. They can get loose. And what you want to do is disconnect from the board, because you do not want to do this next step on the board because you can damage the board. So we'll go off to the side with a very small flat bladed screwdriver. You see this on camera. You come over here and just make sure each wire is seated into the connector, okay? The white and the black are going to be your 208 coming into the board. Your blue is your 208 coming out of the board to go through your high limit. Your orange is the jumper wire on the high limit itself, and that's just telling the board that it sees it coming back from the first one. And then the yellow is the power coming back after it went through the second high limit. So it needs to see both high limits coming back to the board. So it needs to send a 208 on the blue, and 208 coming back on the orange, and 208 coming back on the yellow wire. Okay, sometimes these wires get loose. You have to just make sure you re-secure them. Then come back and install it on the board. One thing to do is make sure you do not mispin it like this. Okay, if you mispin it, it won't work either. So make sure the pins are aligned when you put the connector back. Okay, so pins are aligned. All right, so we can check that for power. If you want to wear gloves, that's fine. I'm going to put gloves on and I'm going to reattach power. Power has been reapplied. I have on gloves now, and I'm going to bring the multimeter back into the frame. Okay, I'm going to set it for volts AC. Okay, check your meter. It might go to AC first or DC first, so you might have to press the mode. Mine's on auto, and sometimes you still have to adjust it. What we're gonna do is first is just gonna check to see if we're getting 208 into the board. Okay, so take your meter leads, and there's little metal tabs here on the connector. Now this is AC, so it doesn't matter where you put the red or the black. You should see 208 on the display, or this might be 240 as well. Okay, this one is a dual voltage unit. So we have 236 there. Now what we're gonna do is, when we turn the unit on, I'm just going to move the one lead over to the blue wire. If we don't see that voltage coming out, something similar, right? You might have some voltage drop. If you don't see the same voltage or similar voltage coming out, it's like 3 volts, that'll trigger the error 17 as well. Okay, so what we can do is press the power button. I have my assistant turn the power on for me. And this goes quick. And once it clicks on, all right, you should see 208. I know we have 208 there, or 230 on this one, because I heard the contactor click. And then we would check from white to the orange as well. If you lost power there, that's telling you that high limit is open. Even though we tested it before and it showed it had continuity, you might have high resistance where it's not allowing the power to go through. That's the only time your ohmmeter is going to lie to you, is because it has continuity doesn't mean it has a good connection. All right, we'll move over to the yellow wire. Once again, you should see that same number, about 230, 235, somewhere around there. Okay, once again, if we had 0 volts or say 3 volts, whatever, it's not line voltage, that is telling us that we have an issue with that high limit. Could be, once again, could be dirty connections in there, high resistance. Okay, another fault with error 17, it could be an error with the amperage setting here. This is a quick diagram, schematic, and I'm going to point to the donut over here. This little donut here, it's the amperage sensor on the board. I'm going to point to it on the board as well. This is your amperage probe sensor. If it doesn't sense amperage going through the circuit, it will also trigger an error 17. That can be caused by an open solid state relay. That is most of the causes you're going to see for error 17. Okay, so one other thing it can be is a contactor issue. All right, we heard it fire off before. I removed the nuts to hold this cover on here to expose the contactor. All right, the contactor has the yellow wire from the high limit, and the white wire over here, that's going to complete the circuit. So you can check for 1,000 ohms, plus or minus 10%, on your coils to see if your contactor is good for the coil. If that is good, you might have an issue where one of the two poles on the contactor is sticking open. You can actually open that up. We can do that really quick here. And unplug the unit. So you get these sparks or arc flashes in the video. Right, there we go. Okay. Can you see these knuckles here? Can you see these pieces here? Okay. I call them knuckles because that's what they look like. What you do is to check it by pushing 3 times fast on one side and 3 times fast on the other side. If you feel it binding in any of those directions, then you know the contactor is default with the contactor, or you can see if there's any buildup on the contactor tips. If there's anything blocking there, some kind of debris, that'll stop the transfer of power. That'll give you error 17. The board is looking for amperage through the circuit. If it doesn't see amperage going through this donut here, that's what triggers the error 17. We spoke about the relay that could be faulty, could be stuck open on one or both legs, because there's 2 heating elements in this unit. So if it doesn't see the amperage and at the right time, it'll give you error 17. Once again, just check your contactor as well. Check your coil for about 1,000 ohms, plus or minus 10%. If it's all within specifications, check to see if your contactor tips are filled with debris or anything that could cause it to not allow the power to go through.